Okay, so this is the question from the Final Jeopardy, requiring you to determine the VO2 max of an endurance trained gentleman who is age 70, meaning that his max heart rate is going to be estimated at 150 beats per minute. And this is determined or estimated because of the 220 minus age equation, where you subtract his age from 220 and you get 150 beats per minute. Now, from here, we're going to have to convert something for the AVO2 difference to go any farther. We're just going to prepare the variables before we share the equation. So an AVO2 difference of 12 milliliters per decibel is not really usable right now, but to convert it into something that makes sense, we're just going to remember that every deciliter is 100 milliliters. So I'm just going to do 12 over 100 milliliters because, again, 1 deciliter equals 100 milliliters. And from here, you're going to cancel these two units. And what you're going to get is 0.12. So our AVO2 difference, I'm just going to write all the variables we finish up with here. Max heart rate of 150 beats per minute. And then AVO2 difference of 12 milliliter. No, hang on. 0, 0.12. And then we really don't have to change stroke volume at all because that's going to be the answer we were going to use in the first place. But just for you guys' sake, stroke volume is going to be your end systolic volume, or wait. In diastolic volume minus your, in systolic volume. So for this situation, his maximum stroke volume is 150 milliliters of blood per beat. Now, if you remember in class, Fick's equation is going to be VO2, in this case, VO2 max equals stroke volume max times heart rate max times AVO2 difference. So from here, we're going to place everything into the equation. And again, keep all labels as you go along, just so you don't get mixed up and confused and forget a unit. So VO2 max equals, so stroke volume is 150 milliliters per beat or heartbeat times max heart rate, which was 150 beats per minute, times AVO2 difference, which is thankfully 0.12. So that's unitless. We don't have to go much farther with that. From here, let's go ahead and cancel out some units. Since there's a beat in the numerator and there's going to be a beat in the denominator, I'm just going to cancel these out now. And then we'll go from here and start multiplying 150 times 150 times 0.12 equals, and that is going to be 2,700 milliliters per minute, because those are the only units left, and that's what we wanted to get anyway. So now, once we have this answer, we're going to go ahead and display this in absolute terms and relative terms. And so we normally use the units liters per minute for absolute, and then we use relative milliliters per kilogram per minute. And I completely forgot to bring up the gentleman's weight, which is 75 kilograms. We're just gonna skip along until we remember. So his weight is 75 kilograms. That's important when we express this in relative terms. So to get this in absolute terms, 1,000 or 1 liter is 1,000 milliliters. So 2,700 milliliters per minute divided by 1,000. Oh, we're going to do it this way. We're going to divide this by 1,000 milliliters over 1 liter. So when we flip things like this up to the, if you remember from algebra, flip this up from bottom to top, we get 1,000 milliliters per minute, or 1 liter over 1,000 milliliters per minute. Probably could have done this an easier way, but here we go. The milliliters cancel. You got to divide 2,700 by 1,000, and you get, whoops, 2.7 liters per minute. And then when we want to convert this to relative terms, hang on, let me just denote that that's for this one. Allowed myself to run out of space here. You're going to go back to VO2 max in milliliters per minute, and you're going to divide 2,700 or 2,700. It doesn't really matter. You can say either. 2,700 milliliters per minute divided by 75 kilograms. And your answer is going to be 36 milliliters of oxygen per kilogram of body weight per minute. And that is how you answer the Final Jeopardy question.